So let's assume this is your router 1 and this is router 2, this is router 3, this is router 4 and this is router 5. These are connected in this manner. Here you allocated 23.1.2.3, here 34.1.3.5, it would be 35 actually, and then here 45.1.1.4.5, then 14.1.1 and then .4, then here it's 12.1.1 and here we are having .2, and then in the lane of R3 let's say that we are having 30.1.1.0/24. Now whenever you will enable EIGRP onto this interface, right? So very first thing that EIGRP will do, that it will calculate metric for this network, for this interface itself, and will inject its metric in its own topology table. That will be very first thing that would be very first thing done by EIGRP. So it will calculate metric for its directly connected network. Let's say it was FA2/0, right? So and let's say that its bandwidth was 100 Mbps. So it will calculate metric according to this bandwidth and its delay. Let's say, and you know very well that for 100 Mbps by default delay is 100 microseconds, right? So because by default your delay is 100 microseconds for this interface, so it will calculate metric for it, and it is going to be like 10⁻⁷, which means 7 zeros will be there, and then divided by bandwidth in kbps, which means 100,000, right? And plus total delay by 10, it will be 10 multiplied by 256. So that will be your formula to calculate its metric. So finally it will become, I think, 28160, something like that, right? So it will be, it will be your metric. So now this R3 will install this information in its own topology table, in its local topology table as a directly connected, right? So whenever now R3 will form neighborship with R2 and R5, let's say that it has formed the EIGRP neighborship with R2, so it will be giving its own information to its neighbor, and it will say to R2 that okay, if you want to reach 30.1.1.0/24, right? So what's the meaning of this 28160? This is your FD, right? This is the FD of R3 in its topology table. FD means feasible distance, like total metric to reach your destination prefix. So it was the total metric from R3 to reach this particular prefix 30.1.1.0/24. So its metric was 28160. Now R3 will advertise this information towards R2 that if you want to reach 30's network, then you can reach it via 23.1.1.2, and if you want to reach it via me, then your metric is going to be 28160, right? And if it is given by R3 to R2, so for R2, now I'm talking in perspective of R2, so for R2 it will become AD, advertised distance, or we can call it either AD or RD, right? We can also call it RD, reported distance, because this information is given by our neighbor device, which is R3, that if you want to reach this 30's prefix, then your metric is going to be 28160. Any problem in it? And then finally R2 will calculate its total metric now to reach this destination prefix, 30.1.1.0. so now it will calculate its own metric, and that will be known as FD. Let's say it has become now actually we took it to 8160, but for an example let's assume that it was 100, right? So it will be here 100 AD, and then let's say FD has become now 200. Let's assume it, right, that FD has become 200. Similarly, R3 will be giving this information to R5, and R5 will install this prefix like 30.1.0/24 via 35.1.1.5, and then its AD will be 100, but it will also calculate its total metric to reach this destination prefix. So let's say that FD has become 200. Now similarly, R2 will form neighborship with R1, so R2 will be responsible to for giving an update message to R1, and R2 will inform to R1 that if you want to reach 30.1.1.0/24, then you can reach it via 12.1.1.2, and your advertised distance will be 200. Because R2's FD was 200, so now R2 will advertise its FD towards its neighbor R1, that if you want to reach 30's prefix, then your metric is going to be 200. So because R1 received this update from R2, so for R1 it will become advertised distance. Now it will also calculate its FD. Let's say it has become now 300. Similarly, R5 will be giving this update to its neighbor R4. Let's say R5 said to R1 that you can reach 30.1.0/24 network via 45.1.1.5, and your FD your AD is going to be, your AD will be 200. Then it will calculate its total metric, that will be known as FD. Let's say it has become now 300. Similarly, now R4 will inform to R1. R4 will ask to R1 that okay, you can reach 30.1.1.0/24, you understand, via 14.1.1.4, and your AD is going to be 300. Then it will calculate its total metric, which will be known as FD, that will be, let's say, that is 400. So for R1, now there are two different paths available to reach this single destination prefix, which is 30.1.1.0 in this case. It can reach it via R2 as well as via R4. Now it will be comparing its FD, feasible distance, via both neighbors. So as I said that lower metric will always be preferred. So for R1, best path to reach this 30's prefix will become via R2. So this path will be known as now successor. Remember that best path to reach destination will always be known as successor. For R2 to reach this 30's prefix, this path will be successor. Understood? So successor will be best path actually in EIGRP. So for R1, its best path is via R2. That is why this path has become now successor, or it will be known as successor. Now, as I told you before, that EIGRP is the only protocol which also provides you backup path. EIGRP is the only protocol which can provide you backup path. Means that it will also provide you backup path if it is possible. Because to have a feasible successor, there is a condition that is known as condition of feasibility. So this time you can see that this path via R4 to reach this 30's prefix, right? This prefix can become backup path. But it would become backup path means that feasible successor if it is fulfilling condition of feasibility. Now the question is that what's that condition of feasibility? So remember, to become feasible successor, it is mandatory that backup paths advertised distance must be lower than FD of successor. That is the condition of feasibility. So remember, to become feasible successor, backup paths AD must be, advertised distance must be lower than to the FD of successor. So this is the condition of feasibility. And now you can look at this diagram. This R1 is having this path as a backup path. But now point is whether it will become feasible successor or not, because my I mean, it is possible to become feasible successor, but it is also possible that it will not become feasible successor, because it will become feasible successor in that case only if it is
lower.
fulfilling condition of feasibility. Now, if we talk about the condition of feasibility, that is that backup path's advertised distance, this advertised distance, because this is the advertised distance of backup path, and which is 300 in this case, right? Fine. So in this case you can see that its advertised distance is, I mean backup path's advertised distance is 300, whereas FD of successor is 302. Means that this time FD of successor and advertised distance of backup path is similar, is common. This value is common. But as I said that to become feasible successor, it is mandatory that backup path must have its AD lower than FD of successor. But this time it is equal to the FD of successor, right? So this time it is not gonna to become feasible successor. It will not be defined as feasible successor, or EIGRP will not make it feasible successor. But in case let's say its FD from R4 to reach this 30s prefix is 299. So this is the FD of R4. Now R4 will advertise that okay, if you wanna reach 30s prefix, then your matrix is going to be 299. So for R1 its backup path's advertised distance is now 299, which is lower than to the FD of successor, and now this time it will become feasible successor. Now question is that we know very well that if let's say that there is no feasible successor, right? There is nothing like feasible successor in EIGRP, and its best path is via R2. I mean its successor is via R2. But we know very well by looking at topology that R1 can also reach 30s prefix via R4. That's possible, right? I mean R1 can also reach this 30s prefix via R4. Now if it has not defined this backup path as a feasible successor, and in case if successor goes down, we know very well that R1 will start to forward traffic in the direction of R4. Even if it is not feasible successor, but there is no other way available, there is no other path available except this via R4. So we know very well that R1 can still reach this 30s prefix via R4. So in case if its successor goes down, then it will be very much possible for R1 to reach 30s prefix via R4. It can reach this prefix via R4 very easily without any problem, right? Even if it was not a feasible successor. Now let's take an example that it is a feasible successor. If successor goes down, then definitely traffic will start to go through via feasible successor. So what's the difference? If we are having feasible successor and if we are not having feasible successor, what's the difference in that? Exactly, like it will affect actually your convergence time. It will affect your convergence time in EIGRP, right? See, if there is no feasible successor, there are some rules in EIGRP. If there is no feasible successor, and let's say that your successor has gone down, in that case your router 1 is not gonna to remove this 30s prefix immediately from its routing table. It will keep that prefix in its routing table, but it will start to generate query messages towards all other neighbors. So let's assume that it is not your feasible successor. I mean R1 is not having any feasible successor for 30s prefix. Now let's say its successor has gone down. Now R1 will start sending query messages. So remember that in EIGRP, query messages will be generated by EIGRP in case if any successor goes down. So in case if successor has gone down, then only EIGRP will start generating query messages. So it will send this query message towards R4 that do you have any information about 30s prefix? Can I reach this prefix via you? So in case if R4 is having an information about 30s prefix in its routing table, and of course R4 was already having this 30s prefix in its routing table, right, via R5. So now R4 will provide a reply message that yes, I know, and along with that R4 will also forward its update packet towards R1 that this is the metric. If you want to reach 30s prefix via me, then this is the metric, right? So finally R1 will install this 30s prefix in its routing table via R4. But in case, let's say this time you are having feasible successor, let's say this path was already defined as a feasible successor, we are assuming it, right? So in case now if its successor goes down, then it will not require to generate query messages. It will not send this query towards any neighbor to ask about destination prefix, right? It will simply define this feasible successor as a new successor. In case if successor goes down, then it will immediately define its feasible successor as a new successor without sending any query packet, because it was already having its feasible successor information in its topology table. Understood? So this is the only difference in EIGRP calculation, in EIGRP convergence, in case if it is having feasible successor and if it is not having feasible successor. So if your EIGRP does not have feasible successor, then in case if successor goes down, it will always start generating query messages towards its all other neighbors. And in case if feasible successor is existing, then it will define that feasible successor as a new successor. Right? Fine. Now let's assume that there is no feasible successor. Right? There is no feasible successor actually. Let's say its AD was 300 itself. Right? So this time there is no feasible successor. Now in case if this successor has gone down, right? So if this successor goes down, then R1 will start sending query message. So it will give this query message to R4. Now R4 will send an acknowledgement towards R1 that okay, I have received your query packet, right? Because as I told you that for update, query and reply, for these three messages, EIGRP will use RTP, Reliable Transport Protocol. Means that for all these three packets, for all these three messages, it is mandatory to generate an acknowledgement packet, right? So if anyone has sent an update packet to any neighbor, then it is mandatory to receive an acknowledgement from the recipient. Similarly, if any router has generated a query packet, then it is mandatory to receive an acknowledgement from the recipient. Similarly, if anyone has given reply packet to any neighbor, then it is mandatory to receive an acknowledgement from recipient. Any problem? Fine. So this time R1 has started to generate query packets in the direction of R4. So R4 will receive this query packet. Fine. Now there will be two things. Either this R4 will be having this destination prefix information available in its routing table and in its topology table, or it will not be having that. If R4 is having an information about that prefix for which it received a query packet, then it will immediately provide a reply. It will forward a reply packet towards sender. I mean towards that neighbor from where it received query packet. In case if R4, let's say R4 is also not having any information about that prefix for which it received query packet, then what will it do? It will send that query towards its another neighbor. Let's say it is R5. So now this query will be forwarded by R4 in the direction of R5. In case R5 is also not having that prefix information in its routing table and topology table, then R5 will forward a copy of that query packet towards other neighbors, and they will keep on to send that query packet, to their neighbors, right? And now there is a rule that in case, let's say, because this query was originated from R1, right? So R1 generated this query packet. So there is a rule in EIGRP that whenever a router will start to generate query packet, it will immediately start its timer, which is called active timer, and by default in EIGRP it is, I think it is 180 seconds, right? So that active timer in EIGRP by default is 180 seconds. What does it mean? It means that if, let's say R1 originated this query packet, if R1 does not, if any router does not receive a reply packet, whether it is a negative reply or positive reply, doesn't matter, right? But it must receive a reply packet, right? So it will do wait for 180 seconds. If it does not receive reply in the response of query packet within 180 seconds, then it will announce itself stuck in active state, but after 180 seconds, right? Now there is a rule in EIGRP that if router has announced itself stuck in active state for any neighbor, then it will break neighborship with that neighbor. Then it will immediately break neighborship with that specific neighbor. So because this time R1 moved into stuck in active state for its neighbor R4, so once it will announce itself stuck in active state, you will see that R1 will break its neighborship with R4. It will reset its neighborship actually. So that rule is also, that rule also exists in EIGRP, that is stuck in active. In case if any router has become active, what's the meaning by that? I'm saying that okay, router has become active, which means that router has started to generate query packets. If I am saying that, or if anyone is saying that okay, router has become active in EIGRP, what does it mean? It means that it is generating query packets, but it has not received any reply yet. That's the meaning by active state.
Reset के बाद वो दोबारा establish करता है?
Of course, if there is no problem onto their link, then definitely they will form their neighborship once again. They will again form neighborship in case if there is no problem. But if there is any problem, then your neighborship will not come up.
Problem means क्या
Problem like if someone has filtered your EIGRP based packets.
मैंने कहीं पढ़ा कि वो नेबरशिप ब्रेक कर देता है, उसके बाद जो उस नेबर से लर्न कर रहा था नेटवर्क्स, उनके लिए भी क्वेरी पैकेट जनरेट कर देता है.
But towards all other neighbors. Let's say that R1 moved into stuck in active state for neighbor R4 only, and it was having some neighborship with some other routers as well, right? So in case if it has lost reachability with R4, which means that successor has gone down, right? So definitely R1 will generate query packets now towards all other neighbors for those prefixes which were received from its neighbor R4. So that will definitely happen because successor has gone down. See, there are some universal rules in EIGRP. Successor goes down. If there is no feasible successor, it will start generating query packets, right?
So feasible successor से response नहीं मिल रहा, यानी feasible successor है ही नहीं, तो उसने query
generate किया,
अब उससे उसको उस नेटवर्क का रिस्पॉन्स नहीं मिला, तो उसने रीसेट कर दिया.
Reset after 180 seconds, right?
और जो भी नेटवर्क्स उसको लर्न होते हैं फिजिकल
because now it has broken neighborship with that neighbor, right? Which means that its successor for all those prefixes which were received from that specific neighbor has gone down one. Is not it? So successor for all those prefixes has also gone down which were received from that specific neighbor R4, right? So this time it will start generating query packets for all those prefixes which were received from R4 from its neighbor R4, and this time it will generate those query messages in the direction of all other neighbors. So here in EIGRP it's all about hello, update, acknowledgement, query and reply. Successor goes down, will generate query packet. If any router receives a query packet, then it will look at the at that prefix for which it received query. If it knows about that prefix, then it will generate a reply packet, will send it towards that neighbor from where it received a query packet. If it doesn't have any information about that query, and also it is not having any other neighbor, which means that now it does not have any information about that destination prefix, so it will again provide reply to the sender, right, to the querier. But this time it will be negative reply that I doesn't know anything about this, right? So in this way EIGRP will define feasible distance, feasible successor, feasible successor, feasible distance, advertised distance, active, passive. Do you know? I mean, like if your prefix is available in the topology table of EIGRP, then there are some states. In EIGRP, we are having some states available actually, and those states are like active and passive, and these states will always be available in topology table only. So in topology table, if your prefix is in active state, what does it mean? And if it is in passive state, then what does it mean?
In active state, it means that it is looking for routes from
Active, which means it is generating query messages for this prefix, right? Passive, that everything is fine. Right?
So, in previous topology, when R1 was generating a query message for that prefix that it lost from receiving R2, then what it will do for those 180 seconds? It will keep that prefix.
Of course, it will keep that prefix in its routing table
for those 180 seconds. And so, if we just have R1 and R2 in our topology, and R1 is stopped to receive the prefix that is generating by the R2, then what it will do? It don't have any feasible successor. There is just two routes, R1 and R2. And R1 is stopped to receive the prefix that is generating by the R2. Let's take an example.
R1.
Yes, sir.
You are having only two routers, R1 and R2.
Yes, sir.
Let's say R2 has stopped. I mean, see, let's say now. Actually, there is nothing like periodic update,
Okay.
right? So you can't say that it has stopped receiving an update.
Yes, sir. Yes.
hello message.
If you have stopped receiving hello packet, then it will break neighborship. And in case if any interface is going down, then it will send update packet to its neighbor
Okay,
with highest metric,
yes, sir.
which means it will inform to R2 that this prefix has gone down. So that R2 will immediately remove this prefix from its routing table.
Okay. In this case, there will be no query message.
Nothing, because this time it is not getting query.
Mm-hmm.
It is receiving update packet because interface went down.
What is the meaning of the highest metric?
That's what I told you, that in update packet it will specify the highest metric, like 4.2 billions.
Okay.
Or highest delay, right? It will specify that, okay, highest delay, which means that it will never be reachable now. I'll show you that, okay, what kind of packets are generated by EIGRP if any link goes down. So hopefully you have understood all these basic concepts of EIGRP, like successor, meaning by feasible successor, condition of feasibility, right? For loop prevention in EIGRP, it has split horizon. split horizon is by default enabled, right? But in case what if you have disabled split horizon? In case if you have disabled split horizon, which means that there can be a routing loop, but again there will not be any routing loop in EIGRP because it is using a strong algorithm that's called dual to prevent network from routing loops. One more thing that I would like to tell you, we are having a condition of feasibility over here, right, to configure feasible successor. I mean, to become feasible successor, that is mandatory to fulfill the condition of feasibility. So why do we have this condition of feasibility in EIGRP? It is just because of loop prevention. You know what, let's say this is R1, this is R2, and this is R3. Let's say there was a prefix 30.1.1.0/24. Got it? I'll let you know that how does it really help us to, or how does it really help to prevent our network from routing loops. Let's say it is 23.1.2 and this is .3 and this is 12.1.1 and this is .2. So this time R3 will define its own FD to reach this 30s prefix. Let's say it is 100, right? So now R3 is gonna to send this update towards R2. And if you wanna reach 30.1.1.0/24, then your AD is going to be 100 via 23.1.1.3, and let's say FD has been defined now as 200. FD has been calculated as 200, right? Now R2 will forward this update to R1, that if you wanna reach 30.1.0/24, then your AD is going to be now 200, and let's say FD has been defined as 300. Now what if you have disabled split horizon over here, right? Let's say you disabled a split horizon over here, so it will forward this update back towards R2, that if you wanna reach 30s prefix, then you can reach it via 12.1.1, and its AD will become now 300. So if it defines it as a feasible successor, if let's say that there was no condition of feasibility, right? And because this time R2 has also learned this update from R1, that okay, it can also reach this 30s prefix via R1, so it will make it as a feasible successor. It will define it as feasible successor if there is no condition of feasibility, right? Because what was the meaning by a feasible successor? Which means that backup path, right? And which path is the backup path from where you are receiving your prefix apart from primary path, right? Let's say for R2 its primary path was via R3 to reach 30s prefix, but similarly R2 is also receiving update for the same prefix via R1 as well. So this R2 can define this path as a backup path in case if there is no condition of feasibility. And if there is no condition of feasibility, then R2 is going to define it as a feasible successor. And now in case if successor goes down, then R2 will define, or R2 will install this prefix in its routing table via R1, and R1 was already having this prefix via R2, so packet will start to, so there will be a routing loop in case if there is no condition of feasibility. So there is always condition of feasibility. So without satisfying condition of feasibility, it is not possible to define backup path as a feasible successor. So this time whenever R2 will receive this update coming from R1 to reach 30s prefix, it will check its AD, advertised distance, and then it will check its own FD to reach this prefix. That was 200, and this time AD itself is 300, which is higher than FD of successor, right? So it is not gonna to define this path as a feasible successor. That is why there will not be any routing loop. Any problem? Fine. Now in topology table, there is a topology table in EIGRP, right? If you talk about the components of topology table, then in topology table it has three types of prefixes actually. One, like it will be having information about your successor. then feasible successor if it is available, and then possible paths as well. EIGRP also maintains possible paths in its topology table. So in topology table it will be having three different types of prefixes like successor, feasible successor, as well as it can keep possible paths. Summarization, of course, it supports summarization, and because it is a distance vector routing protocol, you can configure route summarization on any router in EIGRP, on any router, anywhere in the network. Then authentication, of course, it supports authentication, and that is only and only MD5. But now, in named mode, it has started to support SHA as well, which is latest hashing protocol, or which is good, or which is better than MD5. Now we are having some features in named mode. I'll be discussing them during practicals only. Like we are having here one feature of add path, one feature of like FRR, fast reroute. Here in EIGRP we are having a concept of FRR, fast reroute, that is supported in named mode only. Even add path feature is also supported in named mode only. So I will be discussing these features along, with named mode only, right? So apart from that, if we compare EIGRP with RIP, in EIGRP along with the network command, we can also use wildcard mask. So these wildcard mask bits will help us to enable EIGRP only on those interfaces where we want to enable EIGRP. Because in RIP we were having that problem. Do you remember that in RIP we were having problem, like it was also possible to enable RIP onto those interfaces where we don't require to enable RIP. As I already given you an example of that situation, let's say that this was a 0 by 0, and that was 0 by 1, then it was having 0 by 2, 0 by 3. Here it was having an IP address 10.1.1/24. Here it was having 10.1.2.1/24. Here it was having 10.1.4.1/24, and here it was having 3.1/24. Now, in case if network in router mode, if you give network command like 10.1.1.0, you will see that RIP will get enabled onto all these interfaces automatically, and you cannot stop it. You cannot restrict RIP to enable only on selected interfaces. That was the problem with RIP. But in EIGRP, of course, we can enable EIGRP only on those interfaces where we want to enable it. Let's say I want to enable EIGRP only on this interface. So its IP address is what? 10.1.1.1. Then I can provide its wildcard mask 0.0.0, because you know very well 0 means must match. So this time you will be saying network 10.1.1.1 and then 0.0.0.0, which means that EIGRP will get enabled only on that interface which is having an IP address 10.1.1.1.1 itself. So this 10.1.1.1.1 is configured only on this interface. That is why EIGRP will get enabled only on this interface. So basically, this is really helpful. This wildcard mask value is really helpful in EIGRP to enable it only on selected interfaces. Fine. So let's start doing practicals of EIGRP. First of all, I will cover classic mode, and then after I'll go for named mode. EIGRP, and then we can take any AS number, but make sure that in your organization you are using a common AS number, because by default prefixes can move from one AS to another AS, and also if you are running different ASs onto two different routers, then they will never form neighborship. To form neighborship, it is mandatory that both peers must be in same AS. So router EIGRP 100, we can say no auto summary, because by default auto summary is enabled. Even I will prove that. Then I'll say network 155.1.0.0. Then I can use wildcard mask 0.0.245.245. However, it is not required because I'm taking it on class full. Then I can say network 150.1.0.0 and then do show history. Fine. Auto summarization is by default enabled in EIGRP. You can look at switch 4. Show IP protocols. Default K values, K1 is equal to 1, K2 0, K3 1, and again all remainings are 0 as well. You can see, you can look at K4, K5. These are the default K values. Maximum hop count is 100. In RIP we are having 15, but here in EIGRP it is 100. It can go up to 255. By default variance is 1. EIGRP supports unequal cost load balancing. I'll be discussing that with you, and we will perform that actually with the help of variance. But by default it is 1. Then you can see that auto summarization is in effect, which means by default auto summarization is enabled. But remember that in iOS 15 by default this auto summary is disabled. In iOS 15 this auto summary is by default disabled. Tomorrow I'll perform, in next class I'll perform practicals in iOS 15 only, because I have to perform, I have to configure wide matrix, so I have to use named mode, and named mode is supported in iOS 15 only. So in next class,
EIGRP NSF aware rule.
this is non-stop forwarding actually, and this is the feature of MLS. On MLS you can enable this feature, MLS multi-layer switches.
तो ये क्या होता है, किस चीज के लिए होता है? तो OSPF भी NSF अवेयर होता है?
हाँ, सभी NSF अवेयर होते हैं, सबके सब राउटिंग प्रोटोकॉल्स. अब इसको मैं कैसे समझाऊँ, बहुत बड़ा कॉन्सेप्ट है ये. आपने सुना होगा, हम दो सूप कार्ड यूज़ करते हैं MLS पे. एक एक्टिव होता है, एक स्टैंड बाई होता है. फिर रिडंडेंसी मोड भी डिफाइन करते हैं. आज के टाइम में हम यूज़ करते हैं SSO, स्टेटफुल स्विच ओवर, in which it will come up in less than 1 seconds in case if active goes down, right? तो उस केस में हम NSF इनेबल करा लेते हैं, नॉन स्टॉप फॉरवर्डिंग की, बीच में कोई आउटेज ना, ट्रैफिक के लिए होता है. So now you can look at gateway. Gateway is that address from where it is receiving updates. So this time this switch 4 is receiving updates from switch 2 only, and the IP address of switch 2 is what? 108.8. So this is the gateway of information, and then after you can see that auto summarization is by default enabled, and then you can look at the routing table, show IP routes. Wow, this is unexpected result. See, all 150's networks are also on /24, and these 155's networks are also on /24. both of them 155's network, 150's network, both of them belongs to class B. But all 155's networks are available in the routing table. It has learned all 155's network, but it has not learned any single 150's network. Any single 150's network. What's the reason behind it? Auto summarization is enabled, I agreed. But auto summarization is enabled for all. I mean for entire EIGRP, not for 150's range only. It has learned all 155's network, and these 155's network are configured in between routers on their WAN links, on their WAN interfaces, right? You can look at this diagram. It has learned all 155's network, this is for, but it has not learned any single 150's network. There is one entry which belongs to 150's network, but it is configured towards null zero. Why?
Summarization कर रखी है हमने.
Yes, summarization is, auto summary is by default enabled. Actually, it is all about contiguous and discontiguous networks. Remember, even if you are running RIP version 1, it supports contiguous networks. But RIP version 1 itself does not support discontiguous network. Actually, we should not say that, okay, it supports classful networks and it does not support classless networks. That's completely wrong. If we are saying that in case if auto summarization is enabled in EIGRP, then it will not support classless networks, that is completely wrong statement. It's all about contiguous and discontiguous networks. Remember that even if auto summarization is enabled, routing protocols will support contiguous networks, but will not support discontiguous. If you disable auto summarization, because in RIP version 1 it is not possible to disable auto summarization, right? It is possible to disable auto summarization in RIP version 2 only. So RIP version 2 can support discontiguous networks. EIGRP can support discontiguous networks, but in case if auto summary is disabled. If auto summarization is enabled in EIGRP, then it will also support only and only contiguous networks. Now you can look at this diagram that if R5 is giving an update of 155's network, then you will find that on its all WAN interfaces we have configured network from the same class with the same prefix length from same subnet. Like here on all WAN interfaces I'm using 155's network, 155's network, 155's network, 155, 155. Even if I start to use similar 155's network in their lane, then you will see that they will perform routing. They can perform routing because at that moment it will become contiguous. I mean, it will be having only and only contiguous networks. But this time you can look at like their loopbacks, like their lanes are using lanes are using networks from 150's range, whereas those updates has to go through those interfaces which are having an IP address from the range of 155's network. That is different from 150's, right? But in case if we take an example of 155's network itself, if those updates are going out from those interfaces which are having an IP address from the same subnet, 155's network, right? So it will become contiguous network. So that is why due to contiguous networks only this is possible to perform routing for them. and it is receiving all of them. It is receiving all the networks which belongs to 155's network, because these networks are contiguous networks. Even you will get same result in RIP version 1 as well, in RIP version 2 as well, till auto summarization is enabled. Once you will disable auto summarization, then it will start doing support discontiguous networks as well. Understood? Right? Understood? Now I'm going to disable this auto summarization, right? And one more thing, do not get confused here. Now usually we says that okay, this routing protocols, this routing protocol is a classless routing protocol, or this routing protocol is a classful routing protocol. Yes, that's true, that we are having routing protocols something like this, that classless routing protocol and classful routing protocols. Like if you talk about RIP version 1, RIP version 1 is a classful routing protocol. You know why? Because RIP version 1 does not carry subnet mask information along with their updates, whereas RIP version 2 will carry forward their prefix length along with prefixes, subnet mask information along with update messages, along with updates, right? So that is why we call RIP version 2 as a classless routing protocol. But we will never say that okay, this routing protocol supports classless networks or classful. We can say, but actually or technically we will always say that okay, it supports contiguous networks, or it supports contiguous and discontiguous both. Some of the routing protocols supports only and only contiguous networks, and some routing protocol supports both of them. Like by default RIP and EIGRP. By default RIP and EIGRP, both of them supports only and only contiguous networks till iOS version 12.4. But if you take an example of EIGRP in iOS 15, then by default, because auto summarization is disabled now, so by default it will support contiguous and discontiguous both networks. In case if you take an example of OSPF, because in OSPF nothing like auto summarization. In OSPF there is nothing like auto summary. So by default OSPF supports contiguous as well as discontiguous networks. So let's start it from R1. Say not a summary to show history. And like switch 4 was having one entry in its routing table as summary address towards null interface. And I told you before that in EIGRP, whenever you will configure any summary address, whether it configured it automatically or you configured it statically, it will always put that entry in its local routing table towards null zero interface. Right? You can even look at the routing table of switch 4, so it was having this entry. Just because of some summarization, because it configured the summary address automatically, right? So router EIGRP 100 and then say not a summary. And this time you will see that all networks will be available here individually. You can look at this. Let's capture some packets of EIGRP here. Hello packets, right? You can open hello packets. Cisco EIGRP IP protocol number is, tell me, 88, and it is always multicasted. Then destination MAC address will also be multicasted. That's why it has been 0A. You see 01005E00000A, because 10 which means A. And then in hello its opcode is 5, and then you can look at the parameters. You will find these k values. So actually you can look at this k6, right? Even it was available in classic mode as well, but it was not showing by EIGRP in any output, right? Hold down timer is by default 15 seconds. So it is also this information is also contained by hello packet. AS number is also there inside the hello packet. Apart from that, it's like iOS version and something like this, nothing else. So this is the information contained by hello packet. There is no authentication, that is why it is not having any information about authentication. If you have configured authentication, then it will contain that information too. And if you have configured your neighbor statically, then your hellos will be unicasted, right? So by default in hello packets, its opcode is 5. Now I'm gonna to reset its neighborship. Clear EIGRP. Fine. So you can look at this output. Hello update. Update is given by switch 2 is this one. Yes, this is the update given by switch 2. You can look at this update packet. This is acknowledgement actually. Okay, it is update. Yes, it is having all those prefixes. Fine. So this is the update packet, and by default opcode is what? 1. In REP we were having that in a single update packet it was possible to keep maximum 25 prefixes, but in EIGRP we do not have such limitations. In EIGRP we do not have such limitations, and if there is, then I don't think so that there is any limitation, but you can search it up. Search about it, that is there any limitation for maximum number of prefixes in a single update packet in EIGRP or not, right? It is your work. You can search about it. Now you can see that in this update packet we are having AS number. Then you can also look at routes, that all routes are also available in it. All IPv4 routes. And not only IPv4 routes, you can see along with each and every route, it is having that much information. You can look at this. That much information is attached to a single prefix. That's the biggest, this is the difference in between BGP and all other routing protocols. I will let you know during BGP. But here you can look at its update packet. Along with a single prefix, it is having a lot of information, like next hop address. By default, same as RIP, it is also having 000. Then scaled delay, scaled bandwidth, MTU, hop count, reliability, and load. And tag value is also there. Some flags are also there. Let's say that route source is withdrawn, route is active, route is replicated. So if anything is happening, then it will specify here. If route has become active, then this bit will be turned on. Understood? If any route has to be withdrawn, then this bit will be turned on. Prefix length /24, and your prefix is 58.0. So the same information is, yes,
replicated the problem. Replicated. Third bit figure. Route is replicated.
Replicated. I'll let you know that in which condition it will generate this replicated. I don't remember right now the meaning of this replicated. Fine. Then you can look at all other entries, that each entry is having that much information. Understood? Then after, we can also configure here an acknowledgement. Okay, you can also look at the acknowledgement. That acknowledgement is opcode is same as hello. But here you will look at that it will be containing acknowledgement number. If it is a normal hello, then it will never contain this acknowledgement number. If it is a normal hello, as you can look at this hello, so you will find that there will not be any acknowledgement number. So in case if your hello is actual hello, then its acknowledgement number would be 0. If it is an acknowledgement, then it will be having a acknowledgement number. But acknowledgement packet is not a separate packet actually. It is a hello packet, and it is using hello packet as an acknowledgement too.
इसमें 39 सीक्वेंस और राउंड अपडेट हो रहा है. यहाँ पर सीक्वेंस 39 है ना.
हाँ हाँ,
और वो हेलो होगा उसका 38 होगा.
वही आएगा वापस. So let's say that it is generated by, you see, 108.8 source was this, and you can look at this, that this update was unicast update, right? Okay, so now its sequence number is 39. Then 10 will be giving an acknowledgement. This acknowledgement packet is given by an acknowledgement number is 39, because switch number 4 means dot 10 received an update with sequence number 39. So the same number will be forwarded by recipient as acknowledgement number, as it received sequence number in received update packet, right?
Both will be same.
Of course, that must be same as TCP.
It is sending the unicast update just because of that it has already sent the multicast update.
Of course, it knows that okay, this neighbor is existing over there, and I need to send update to this neighbor. So hopefully you have understood now this whole process. Now let me show you that it will generate a query packet, right? If any successor goes down. So I'll show you that, and to achieve that, actually what we'll do, let me show you switch 2's routing table or topology table. So EIGRP topology, you can look at 155.1.5.0. its successor is via R5, because it is the loop back of R5. So definitely switch 2 is not getting any information about this prefix from its neighbor switch 4. So that is why it is having only and only successor in its topology table. You can look at the output of switch 2. So it is having only successor. Now in case if I shut down this link, if I shut down this loop back onto R5, so R5 will inform to switch 2 that okay, it has gone down. Then switch 2 will see that okay, my successor has gone down. So it will try to reach this prefix via its neighbor switch 4. So it will generate a query packet in that condition, right? So let me show you that. So I'm going to capture this link as well. Previously I was capturing only and only a link in between switch 2 and switch 4. But this time I'll be capturing this link so that I can show you that R5 has generated one update packet, right? So let me shut down the loopback of, sorry, it is loopback 0. So on R5 I'll shut down this loopback 0, and then you can look at this. So actually it has generated query packet, right? Query, because its successor goes down, even R5 successor went down, right? So it generated query packet, and in this query you can see that its opcode is 3, and for which network? 150.1.5.0. and then you can look at its flags, that route is active, and then it will forward this query to our switch 2. Switch 2 received this query from R5. Now switch 2 was not having any information in its topology table. That is why it generated one query packet in the direction of and C query is multicasted. So you can look at this query. Now this query is generated by switch 2 in the direction of switch 4, right? And in this you can see that delay is maximum and route is active. Then switch 4 received this query, and because switch 4 was not having any information about that prefix in its topology table, and also it is not having any other neighbor now, so it is mandatory for switch 4 to forward a reply packet. And in this reply you can see that what it included actually. So in reply packet you can see that its scaled delay is still same as previously, right? Which means that it does not have any information about this prefix, right? And whenever this switch 2 will receive this reply from switch 4, then switch 2 will also forward a copy of, will also forward that reply towards R5. And as I told you, that reply will always be unicasted. So reply, you can look at this, that it has generated by switch 2 towards R5, because switch 2 received reply from switch 4, then switch 2 will further forward that reply towards R5. You can look at this. The delay is maximum, which means that now R5 will remove this prefix from its topology table. So now I will prove stuck in active state, right? As I told you that in case if any device has generated a query packet towards its neighbor, and if it does not receive any reply in the response of that query till 3 minutes, then it will start to announce itself for that particular neighbor as stuck in active state. So we are going to perform that, and once again to do that, actually what will I do? Once again I will move on R5 and I will say no shutdown its loopback, so that its loopback will come up, and once again it will start advertising this prefix towards switch 2 as well as switch 4. So now switch 2 and switch 4, both of them will receive this update. Let me show you that this update will be forwarded in that direction. So this update has been given by, you see, R5, and it has been multicasted, right? You can look at this, and it is multicasted, and if it does not receive an acknowledgement, the next time it will unicast it, right? So now that's fine, that it has generated update and it has given this update to switch 2. So now switch 2 is receiving this prefix from R5, and then switch 4 has also received it from switch 2, and it is also it has also installed this prefix in its routing table via switch 2 itself. You can look at this. How can I achieve this stuck in active state now? Do you know that how to change timers, hello and hold down timer in EIGRP, right? So I'm gonna to do that. I want that in case if I put any ACL on switch 2's F0 by 0 to filter all EIGRP packets. So I know that switch 2 will break its neighborship after 15 seconds. So what will I do? I will move at the end of switch 4, and at the end of switch 4 I'm gonna to configure its hold down timer as 10,000 seconds. And you know that this hold down timer will be carried forward in hello packets. So it will inform to switch 2 that okay, you have to hold for 10,000 seconds now before breaking neighborship if I do not send any hello packet towards you, right? So now you can look at switch 2 and you can see its hold down timer has been changed. Is not it? So remember, in EIGRP, if you change hold down timer on any one of the device, then its real effect will be on its neighbor, because neighbor has to do hold. Neighbor has to put itself onto hold if it does not receive a hello packet from its neighbor, right? So that is why we have defined this hold down timer from the end of switch 4 itself. Switch 4 has informed switch 2 that you have to do hold for 10,000 seconds before breaking up neighborship with me. So now switch 2 is not gonna to break this neighborship for next 10,000 seconds. Now let me show you that how can we filter these EIGRP packets coming from switch 4. So I can say access list 101 deny EIGRP any, then access list 101 permit IP any, and then on to F0 by 0 I can say IP access group 101 in which direction. So it will start filtering all incoming EIGRP packets, but it is not going to break neighborship. It is not going to break neighborship. But whenever switch 4 will send any reply packet, it will not be delivered onto switch 4. Are you getting my point? And now you can look at switch 2, show EIGRP neighbor and its hold down timer. You see, it has been decremented by 10 seconds, which means it has stopped receiving hello packet from there. But it is not going to break neighborship at all, because it has to do wait for 10,000 seconds before breaking up its neighborship, right? So this time even we can try to communicate with the loopback of R5 ping 150.1.5.5. So you see, because all other traffic is allowed via ACL, right? So we can still ping with the loopback of R5. And now let's move again back onto R5 and let's shut down its loopback 0. Shut it down, right? So once again it will generate a query packet. You see that it has generated a query packet, and this time it has not received any reply yet, right? So that now you can look at, and even this switch 2 will also generate a query packet. You can look at this, that it is generating query packet. You see, query. It is sending, it is keep on to send query packets because it is not receiving any reply from there. So switch 2 will keep on to send query packets towards switch 4. Reason? It is not getting an acknowledgement from switch 4 because acknowledgement is coming in the response of query, but that acknowledgement has been dropped by that ACL. And now you can look at switch 2 and show IP route. Is there any route like 150.1.5.0? There is, and via R5 itself. And even you can look at its topology table, show IP EIGRP topology, right? And then you can look at this prefix 150.1.5.0. Yes, that is. And you can look at remaining replies from 108.10 because we have generated a query message towards this neighbor, but we have not received any reply from there yet. I mean, till now we haven't received any reply from there, right? Even you can look at this output as well. So IP EIGRP topology 150.1.5.0 245.245.245.0, and then you can see that this is the topology table, and it received it from 58.5, and then here waiting for one reply. State is active. Have you understood it now? So still it is having that prefix available in its routing table. So it will wait for next 180 seconds, and then after it will break its neighborship. It will reset its neighborship just after 180 seconds. Until that you can look at R5 as well. Show IP route. Is there any 150.1.5.0? Because it was directly connected. That is why it is not having that prefix available in its routing table. But if you look at its topology table, so IP EIGRP topology 150.1.5.0, and then its subnet mask, then you can look at this that it is also waiting for one reply because it has given query to switch 2. Switch 2 has given an acknowledgement that okay, I have received your query, but switch 2 has not given reply yet because switch 2 is waiting for a reply from its neighbor switch 4. So now switch 2 has to do wait for next 3 minutes, and after 3 minutes it will break its neighborship. Show IP EIGRP neighbor. It is still having neighborship. You will see that after some time it will break neighborship with its neighbor 108.10, and then after we will see that this problem will get resolved. Actually, you see, stuck inactive. It started to announce itself in stuck inactive, and immediately it has broken neighborship with switch 4. And this time neighborship is not gonna to come up once again. You know why? Neighborship is not gonna to come up
ACL apply.
because ACL is already configured, right? That is why neighborship is not coming up. But it has proved now that if router does not receive reply within 3 minutes, then it will announce itself in stuck in active state, and then it will break neighborship. Right? And now you can see that show IP route, even that route has been removed from here now. That 5.0 is not longer available in its routing table. Previously it was there. So this is stuck in active state. So of course, due to stuck in active state, problems can occur in our network, right? Brief outages can be there due to stuck inactive, right? In some cases, routing loops can also occur due to stuck inactive, right? Unnecessarily, unwanted information will be propagated throughout the network, right? So this kind of problem can occur due to stuck inactive state in EIGRP domain. So to prevent our EIGRP from stuck inactive state, we are having some solutions over here, right? We can use summarization as much as possible. We can use stub routing. So I will perform stub routing in EIGRP, but later on, now I just wanted to show you that how stuck inactive state can occur in your network and what will be an effect onto your network if stuck inactive state occurs onto any device, right? So that was the effect actually, and in this way stuck inactive state can occur. Yes
सर आपने वो बोला कि 180 सेकंड के बाद वो नेवर से ब्रेक कर देगा बाय फोर्सली हमने तो वहाँ पे लगा दिया है
ACL
नहीं 100 सेकंड होल्ड डाउन टाइम लगा दिया है ना, तो 100 टाइम के बाद ना नेवर से ब्रेक करेगा।
नेबरशिप तो ब्रेक हो चुकी है, वो तो पहले ही हो गई। वो तो जैसे स्टक इनएक्टिव स्टेट में गया नेबरशिप उसने क्लीन कर दिया था, दिखाया था यहाँ पे मैसेज आया था ये। That's the meaning, that's what I wanted to show you actually. If once it will start to announce itself in stuck active state, then it will reset its neighborship, you see.
सर वो होल्ड डाउन टाइम का जो आपने
हाँ तो अब काम नहीं करेगा वो क्यों करेगा?
So the same thing is also happen on R5 also. R5 also break its neighborship.
Why?
Switch to.
Why this time now switch 2 will send a reply to R5?
Okay.
Because now switch 2 has came to know that okay, I'm not going to receive any reply from switch 4, so it will not wait anymore. And now switch 2 will send this reply to R5.
After 180 seconds.
होल्ड डाउन टाइम
Of course.
होता है जब होल्ड होगा तो उस केस में तो स्टक इनएक्टिव होगा,
किसमें?
जितना डिफॉल्ट होगा होल्ड डाउन टाइम 15 सेकंड,
हाँ हाँ
तो उस केस में तो हम मतलब से
क्यों नहीं होगा? अब यहाँ पे तो मैंने ACL से किया ना ये, अब प्रोडक्शन में थोड़े ना आप हेलोस को ड्रॉप करोगे, वो तो सिर्फ आपका रिप्लाई नहीं आएगा ना, एक्नॉलेजमेंट भी आएगी वहाँ पे। तो क्वेरी आप भेजोगे उसकी एक्नॉलेजमेंट आएगी बट रिप्लाई नहीं आएगा वहाँ पे। बट यहाँ पे मैं ऐसा नहीं कर सकता कि सिर्फ और सिर्फ रिप्लाई को ब्लॉक करूँ। देखो ट्राई करके ACL में, इट्स इट पॉसिबल? मुझे नहीं लगता। एक्सेस लिस्ट 101 डिनाई EIGRP है ही नहीं, मैं रिप्लाई अकेले रिप्लाई को ब्लॉक नहीं कर सकता।
सर व्हाट अबाउट
हाँ ऑन स्विच 2, आई एम ऑन स्विच 2 itself.
what about the connection between switch 2 and
Switch 2 and
R5?
R5, it is there, they have their neighborship.
आपने R5 पे लूप सेट किया था ना,
जी
तो इसमें क्वेरी मारी थी,
हाँ जी
ठीक है, और स्विच 2 रिप्लाई उस स्विच 2 ने एक्नॉलेजमेंट दे दी उसका, बट रिप्लाई पैकेट नहीं आया। लेकिन मेरे स्विच 2 है, इस पे तो ACL हमने स्विच 4 की तरफ से लगाई है,
हाँ
तो इसके लिए तो रिप्लाई भेज सकता है ना।
क्यों भेजेगा? स्विच 2 भी तो वेट कर रहा था ना रिप्लाई का, लेकिन स्विच 2 के पास तो अपने पास तो इन्फॉर्मेशन थी नहीं, तो स्विच 2 ने क्वेरी भेजा अपने नेक्स्ट नेबर को, तो अपने बिहाफ पे तो नहीं दे सकता ना वो रिप्लाई।
नेबरशिप ब्रेक हो रही है ये सर रिप्लाई पैकेट के ना आने की वजह से हो रही है या फिर एक्नॉलेजमेंट ना आने की वजह से हो रही है?
रिप्लाई
रिप्लाई ना आने की वजह से।
देख लो ना, स्टक इनएक्टिव स्टेट में गया यार, ये तो इसने शो किया खुद ने, मैंने नहीं कहा ये क्या है?
सर जब R5 ने जनरेट करा तो उसने 180 सेकंड का टाइमर ऑन कर दिया अपनी तरफ से।
एक्चुअली ये पूरा 180 सेकंड नहीं लगा था, उससे पहले ही कर देता है इसको क्लियर।
इसने जैसे इसने क्या किया कि इसे रिप्लाई नहीं मिला 180 सेकंड में, स्विच टू को इसने उसको रिप्लाई दे दिया कि मेरे पास कोई राउट नहीं है, इसलिए इनके बीच में नेबरशिप ब्रेक नहीं है।
Hope you have understood all this process performed by EIGRP. And is it necessary for me to tell you that how to configure authentication in EIGRP? Like, it's very simple. Again, keychain, key number, key string, go to interface, IP authentication, right? Mode EIGRP 100, and then it supports only and only MD5 and classic mode. Then say IP authentication keychain EIGRP 100, and the keychain name was, it would break its neighborship, right? No access group. It will form sorry, this time it is not going to form neighborship because now authentication has got mismatched, right? So you can look at debug command as well. You can move on switch 4 and you can see debug EIGRP packets. So you can see that missing keychain authentication mismatch. So create keychain. Keychain name can be different: CCIE, key 10, key string, key number and key string must match. Go to F0 by 0, say IP authentication, mode EIGRP 100, MD5, IP authentication, keychain, CCIE, EIGRP 100, and then CCIE. So this time you will see that neighborship will come up. So in this way you can configure authentication. In keychain you can configure multiple keys, you can define their timers, means you can define rotational keys. Now it's your homework to to configure rotational keys. You remember that within keychain we can define that, right? Key chain, that was CCIE actually, and then key 10, and then you can define here send lifetime or accept lifetime, right? The only one thing that you must remember during configuring rotational keys, that your accept lifetime must overlap send lifetime. That's the only thing that you must remember or you must configure. Accept lifetime must overlap send lifetime, otherwise your neighborship will flap once. Fine. After that, now let's move on to R5, and you can see that R5 can reach loopback of R1 via R4, via R3, and via R2. You can look at the diagram and then you can come to know that R5 can reach the loopback of R1 via R4, via R3, and via R2. Is not it? So let's move on to R5. Let's look at the topology table for 150.1.1.0 and its subnet mask. Check it out. Yes, all those three paths are available here. It can reach 150.1.1.1, that is the loopback of R1. It can reach it via 45.4, via 35.3, and via 25.2 as well. If you look at the topology table normal, show IP, EIGRP, topology, this was the detail actually. This was detail. If you look at the topology table and if you look at the output for 150.1.1.0, so here it is having only two paths, right? Which means that one is successor and another one is feasible successor. And third one that we saw in details that we found in details, that was possible path. That was not a feasible successor actually, right? So this time you can see that in routing table it is having only one possible path to reach the loopback of R1. I mean only one path available in its routing table to reach its to reach the loopback of R1, that is via 45.4, which is this one. R5 will be reaching this loopback of R1 via R4, but feasible successor is configured via R3 and possible path is via R2. Now you can look at again R5's topology table and check its detail actually, and then you can see that via 45.4 it's FD of successor is 2 3 2 3 4 5 6, whereas you can look at advertised distance of feasible successor of backup path via 35.3, that is 460800, which is lower than to the FD of successor. That is why it has become feasible successor. But this path is not feasible successor. You know why? Because you can look at its advertised distance, which is higher than to the FD of successor, 2323 237. Right? So that is why this path is just possible path. You can look at this via 45.4, it has to cross 2 hop count. Via 35.3 it has to cross, and via 25.2 it has to cross 5 hops. You can see here that R5 can reach this loopback of R1 after crossing 2 hops only. But actually for R3 itself, its best path to reach the loopback of R1 is via switch 1 and then R6 due to bandwidth. Because here we are having lower serial link, lower bandwidth, higher delay. Via Ethernet, higher bandwidth, lower delay. That is why for R3 itself, its best path to reach the loopback of R1 is via 37.7, which is switch 1. Right? Now let's say that I want to perform, let's say I'm on R5 and I want to perform unequal cost load balancing for the loopback of R5. I want to perform unequal cost load balancing for the loopback of R1 onto R5. And this time it has installed only successor in its routing table. If we want to use feasible successor for data, then we can achieve it by modifying variance. Now do you understand the meaning by variance? Variance is kind of multiplier, right? It is kind of multiplier. By modifying variance, we can force our router to install even feasible successor in its routing table. So by default, your variance value on R5, in EIGRP, actually it is 1. Now show IP EIGRP topology. You can look at 150.1.1.0. You see, if I configure my variance as 2, it will work fine over here, right? Because variance will multiply to the FD of successor, and then it will compare that product with all available available FDs. If any available paths FD is either equal to that product or lower than that product, then that will be eligible to install into its routing table. You are simply gonna to multiply your variance to the FD of successor, that is 2 3 2 3 4 5 6. This time it will be same because variance is by default 1, and then it will compare that product with its all available FDs. If anyone is having either equal or lower value than that product, right, that will be eligible. So this value is equal to that product, right? That is why it is eligible to install in its routing table. So this time to install another path in its routing table, what can we say? Router EIGRP 100, we can say variance is what? 2. However, we can configure variance up to 128. So this time I have configured variance as 2. I could configure it as 128 as well. But remember that feasible successor must be there. It can install in its routing table. It can install only feasible successor in its routing table, not possible path. I can look at show IP routing table. For the loopback of R1, now it must perform. So it has installed both routes in its routing table, successor as well as feasible successor. And both of them are having different metrics. That is why we are calling it as unequal cost load balancing. But this time if I trace route 150.1.1 and if I send like 10 packets, you will see that it will be divided in ratio 50-50. Reason being because their metrics are approximately same. It's same. You can look at their value. It's approximately same. So actually it will perform load balancing in ratio of their metric. So if we wanna perform load balancing in ratio of 1:2, let's say one packet via R3 and 2 packets via R4, then we have to do some modification so that metric via R4 to reach the loopback of R1 will become just half to the metric to reach this loopback of R1 via R3. To do that, you can look at R5 and let me show you show IP EIGRP topology 150.1.1.0 and 245.245.245. I'm on R5 itself, I'm not going anywhere else. So via 45.4 its total delay is what? 26,000 microseconds. Via 35.3 its total delay is 28,000 microseconds. Whereas if you talk about the minimum delay is 1544, which means that bandwidth is common via both neighbors. Bandwidth is common because it will be considering only and only minimum bandwidth. Now to achieve this task, what can we say? Either do one thing, configure its delay just half than to the via 35.3. So via 35.3 its delay is what? 28,000. So make it 14,000 via R4. Configure its delay as 14,000. Total delay must be 14,000 via R4. To do that, actually we must be knowing that by default onto loopback its delay is 5,000. Onto 10 Mbps it is by default 1,000. So 5,000 plus 1,000, it has become now 6,000. So here I have to configure only and only 8,000 microseconds. So that total delay will become 40,000. By default here delay is 20,000 microseconds. So now we can look at R5. We can go to like show interface serial 0/1 and by default it is 20,000 microseconds. Then go to serial 0/1 and set delay 800 because it is always configured in the multiple of 10. So by default it will be 8,000 now. You can look at show interface serial 0/1 and then you can see delay is now 8,000, and then once again you can look at the topology table for the loopback of R1 and this time its total delay is what? 14,000. And its total delay is what? 28,000. But still there is not too much difference in its metric calculation because it is not participating only and only delay. It is also it is also considering bandwidth along with delay. So we have to do some more we have to do something else, or we can do one thing. We can decrease delay via R4. So once again I'll move on serial 0/1. Let's configure its delay as 1,000 now. So to make it 1,000 I'll configure it as 100. So this time its delay will be, as you can look at this, it was 14,000, but this time, yes, it has become now only 7,000. But still there is not too much difference, right? There is not too much difference. So what will I do? I will increase its delay via 35.3 because I cannot configure delay lower than 10 microseconds. So let me do one thing. Here it is 20,000. Let me configure it now 40,000 onto serial 0 by 0. So let's move on to R5 and onto S0 by 0 delay 4,000. That will make it 40,000. So now show IP EIGRP topology. Yes, it has become now 48,000. And now you can look at, oh my god, still it is not like. Fine. We can modify its bandwidth as well. Is not it? Via R3 we can decrease its bandwidth. It is by default 1.544 onto its serial 0 by 0 because it is having the lowest bandwidth, right, among all links, because all of them were having 10 Mbps, 10 Mbps, 10 Mbps. But here only this link is having 1.544 Mbps. So onto R5, onto its interface serial 0 by 0, I will say bandwidth 1000 kbps. So this time let me show you that it must be 1000. Fine. Now it is just half. Is not it? Fine. And you know, we cannot modify K values on a specific router, because for K values it is mandatory to match, to form neighborship. So in case if you are going to modify your metric by modifying K values, then it will not affect your path selection, because if you are modifying your K values onto only on R5, then it would break neighborship. And if you are going to modify your K values on other routers as well, then finally your metric calculation formula will be same on to all devices, right? So you have to modify either delay or bandwidth. So this time I have modified delay, along with that I have modified bandwidth to achieve this task. And now you can try to trace route 150.1.1 and then you can say prob 10. So you can look at this output. One packet is going via 4, one is going via 3, one is going via 4, one is going via 3. So you see, that's called unequal cost load balancing. But still I wanted to perform in ratio of 1:2. So which means that the metric must be in this ratio, and I think it is in that ratio. And you can see that it is not 50:50, it is not 1:1. You can see out of 10 packets, show IP route, let me check its routing table. 1.0, okay, so okay, trace route like 150.1.1, and prob is like, let me configure it 20. Yes, it is doing load balancing in that ratio now. You can, I transmitted 20 packets, right? And out from 20 packets it has transmitted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and 12, and 13. 13 packets went via R4, and remaining 7 packets went through R3. So now your load balancing is done in ratio of 1:2. So in case if they ask you to perform unequal cost load balancing in ratio of 1:2 or 2:3 or something like that, then you have to achieve it in this manner. And remember, unequal cost load balancing can be done with the help of variance only. Along with variance, you will require to modify your bandwidth and delay values. Understood? So in this manner, you can perform unequal cost load balancing. And it was really possible to perform unequal cost load balancing by modifying only delay if you were using only and only K3. Do one thing, on all devices, configure K3 is equal to 1 and all other K values as 0. And then after, you will see that your path selection, your metric, for metric calculation, EIGRP will be considering only and only delay. So if you modify only delay, then it will affect your metric calculation. So it will become more easier for you to perform path manipulation. But this time, because in production environment, it is always recommended to use bandwidth along with delay for its metric calculation, right? And by default, Cisco recommends to use both components, right? So it's not like that as per our, as per easy, for our easiness, it's not like that we will stop to consider or we will not consider bandwidth for its metric calculation. We will not make this K1 as 0, right? So it must be 1, K3 must be 1, and with using both components, bandwidth and delay, we must manipulate its path selection, or we must manipulate its metric by modifying bandwidth and delay only.
In case physical successor is present and successor goes off,
It will not generate any query message. It will,
dual configuration
of course, dual is already having that information that it is already having a feasible successor. That is why, in case if successor goes down, then it will define its feasible successor as a successor immediately without generating any query message and all these things.
Then will it try to
Of course, it will try to search another feasible successor in that case. If it is available, then it will make that as a feasible successor. I hope that you have understood all these concepts of EIGRP till now, like how to use variance, how stack inactive works.
जो कल में बात करेंगे कि मल्टीकास्ट रिलायबल पैकेट होता है, उसका यूनिकास्ट नहीं, रिप्लाई नहीं आता,